Thank you. I'm glad you all could make it, and I have a lot of information to share with everyone tonight. The topic I want to cover is setting design team expectations and then planning for success in the design cycle. I have a lot to share. It's usually an hour-long talk. I'm going to try and cram it into 40 minutes so we have time to tell. I'll tell you a little bit about myself, and then I want to make sure I save some time at the end for questions. So we'll get started. So I started taping circuit boards about 40 years ago. That's how we used to do it. We didn't have computers back then, and we used to take precision tape and we put it on Mylar, and we color separated and made artworks that way. And I grew up around that because my dad did that, and I did about 700 different circuit boards that way, just hand taping them. That's how we did the circuits, and then you take that artwork and you put it on some copper laminate, and then you would image it, etch it, and then there would drill holes in it and plate it, and that's how you had a circuit board back then. And it's advanced a ton since then. I started my own business when I was 22 years old. I started designing circuit boards for my father. He had a company, and I worked for him for about 6 years, and I started a design company when he started a manufacturing company. And I ran that for 10 years, and I sold it, and I went to work for an engineering company, ASIC Designs, and I worked for them for about 9.5 years, and I was doing some side jobs, and there was a startup company that I was doing some stuff for, and Intel, a whole bunch of other companies wanted to buy them, and it was an 18-month-old company, and it ended up selling for a lot of money, millions and millions of dollars. And unfortunately, I didn't invest in it at the time, but I did get a good job out there. Intel hired me, and I worked there for about 18 months in the group that did servers and things like that, and then they closed that group down, and I switched into the group that does sort tests. And sort test takes the wafers and tests them. And I worked in that group for a number of years, designing very complex solutions to test the bare wafers to make sure that they're good before they're built. And then I was doing contract engineering while I was at Intel. One of my clients was Tesla Motors. It was a small company that wanted to build a roadster car, and they hadn't even prototyped it yet when I started working for them as a contractor, and I did some circuit boards for that car, and over the years did more, and then 5 years ago I started full-time at Tesla Motors, and it's been a lot of fun. We've designed a lot of products, and our products have been extremely well received. The Model S, as you know, was the Motor Trends Car of the Year award. We just released our Model X car last night, so that's pretty cool. I've done about 3,500 printed circuit board designs for just about any industry you can imagine. I've done everything from baby monitors to grade markers. So a lot of things over the years. So how did I get here? My educational path, my mom was a teacher and my dad was a physics major. My dad was one of those guys that could never leave a napkin alone in a restaurant. He'd always be explaining something. And so I learned to read at a very early age. Before I even went to school, I already knew how to read and write. And then I played a lot as a child with technical kind of toys and things like that. It got me interested in building stuff. I always liked to build things as a child, so I built like lots of models as a young boy. I used to put stuff together all the time, and it was fun. I loved it, and math and science just kind of fit together with that. So I remember being 8 years old, and the man had landed on the moon, and then they came back and they had a parade in Chicago, and I never saw so much ticker tape in my life. It was like 3 feet thick when it was done, and I got to see the astronauts, you know, as they rolled down the street from my dad's shoulders, and I thought that was really, really cool. So I liked engineering because you got to do stuff that mattered to a lot of people. And so I skipped college. You're talking to somebody that took a different path than you're taking right now, and that's okay. And I started a PCB design business because I knew how to do it really, really well. And at the time, it was figuring out to go to college or not. I was already making more as a designer than I would have made if I would have graduated as an engineer. So it was pretty easy math to figure that one out. And then I also started training martial arts in the evening, so I have a third-degree black belt. I'm a head instructor in no-style martial arts. I think it's really important that in your career you really focus on increasing your value and finding out how you can present value to the people that you're meeting, your coworkers or customers, and find out as much as you can about your core area and build your core competence, but then also look to explore the ancillary areas and develop a competency around you and communicate with people around you so that you know what other people are doing. And you should be not only knowing your job, but know the job of the people next to you. And that's really important to helping them do a better job with what they need to do and being better at doing your job. So I've always tried to do that. And you want to learn, you want to learn how you learn best. So as you're learning here at school, I would encourage you to learn your learning style, how you learn best, and then go learn a lot and do a lot of it. Find out as much as you can, and continue learning is a lifelong quest. We never stop learning. You're either growing or dying, and I think we all want to be growing. You're all here to learn. I'm here to learn as well. So always search for the best teachers, the best mentors, and the best experts. And when you are around those people, ask a lot of questions. Never be afraid to ask questions, because there's the only dumb question is the one that you didn't ask. If you have a question, there's probably somebody else in the room that has the same question, and once you know the answer, you'll be able to share that. And then just practice mindful engagement as you go about your studies too. Really do the best you can to learn as much as you can. These are some of the different ways that I've sought continuous learning for myself. A CID Plus, you saw that at the beginning slide, that's a certified interconnect designer. So there's a group called IPC, it's International Packaging Committee, and it's a worldwide organization that trains people in specific printed circuit board design features. I've already talked about martial arts, CEO space. I learned about business at CEO space. This is like software for printed circuit board design. I've also studied sales. I'm a CETA minister, a certified diver. I've taken a lot of different classes, and this is just a very abbreviated list of the things that I've done. I have an extensive library. It's very important to learn, no matter what your path is, to keep learning and walking down that path to gaining more knowledge, you have more to share. I want to cover this right up front so that we kind of have a ground basis of where we're going with this talk, and then I'm going to really roll into it. So at the major level, there's laws. We all need to understand the laws and the principles of engineering. You're all STEM students or aspiring to be. And the laws and the principles are the core knowledge that everybody needs to understand. We all want to be on that same page, and you want to have a very firm foundation of that so that you know how things work and you know what the properties are of things, and you know the terms and the technology of it. And then that's really critical so we can understand and speak the same language to each other when we're doing engineering. And then the strategies or the plans or the methods that we employ to achieve a desired outcome. And then the tactics or the specific directed actions we take to achieve our goals. And then tactics are different than strategies because tactics can change based on the situation, right? So we want to be adaptable. We want to improve our tactics. We want to repeat things that work well. We want to modify them. And then our actions are going to determine our results. And we want to take and chunk down our large tasks into smaller tasks so that everything's manageable. And then we want to prioritize what's the highest value task and work towards that. And then just continuing to learn and understand and apply. So that's a bit of the philosophy I wanted to cover before we got started. So when we talk about setting design team expectations, we're talking about the setting up a prospect for a future good. So we want to do something that's profitable, we want to do something that's good, and that's the expectation we have. And then success is, accomplishing one's goals. We set out a goal, we want to reach it. Today I want to talk a lot about, how we do that. So we set expectations by asking smart questions to find out what the current expectations are. Are they realistic? Are they possible? Can you do it? And then we want to curiously probe and explore the reasons why the expectations are what they are. So we want to we want to bring ourselves to the same page with those around us. And then we want to look at what options can help meet the expectations. So if somebody says, I'd like it in a month, and it takes 6 months, there's going to be a mismatch of expectations. We have to be able to manage that. The ideal outcome finds agreement on the plan scope, the schedule, the cost, and the quality of the project. Now, when we have incongruent expectations is when it gets exciting. A little heat in the room maybe. So seek out the commonality and expectations. Agree on the things you're going to agree on first, and then seek to understand the differences. And then when we do disagree with somebody, don't say you're wrong. Use a little more tact and say, use statements like I feel. Nobody can ever be wrong about how they feel. If you're talking about, I feel, and then if you're going to offer advice, something like to the effect of have you considered is a real good way to frame that. So frame what you're sharing in a way that will be well received. And then it's very helpful to take your past experiences and educate with stories about that. And then nobody likes to be pushed, but we all like good leaders. So be the good leader. And then reframe and refine until you get agreement. And then once you have an agreement with somebody, document it. Because the documentation accelerates the activity. If you can't get agreement, then just disagree and commit to what you think is possible and go from there. So, so when we talk about a printed circuit board design project, who's along for the ride and what are your expectations? So a lot of you are new to engineering, and I want to explain what these different roles are. So PCB designers, that's what I do. I figure out where all the components go, and then I hook them up according to the schematic, and make sure that it's manufacturable and it meets the electrical rules that are required to make that device work. Project managers are going to be looking at all the different people and when they're working on things, and they're going to be tasking and resourcing people at the right time. So project managers are critical to speeding up the flow of the project. Electrical engineers are taking the concepts of what the project is supposed to be and working out the logic and making sure that the right things happen at the right time in the right way. And they're conveying that to me in the form of a schematic. And then that schematic would be, I would take that and put the components onto the board and hook it up according to the rules. Mechanical engineers are going to figure out how much space there is and where it's going to fit. And they're going to be looking at the space constraints, the height, the width, the length of the things, and figuring that out. And signal integrity engineers are going to be taking the circuit board, and they're going to be figuring out properties like what trace widths do we need to have to get the right impedance, to get the right, to get the right signal integrity for the project. It has to work, and they make sure that electrically it's going to do what it's designed to perform. A DFM engineer is designing for manufacture, and they figure out if you can actually make the product. It doesn't do any good to design it and then lose money making it because you didn't figure these things out up front. And then a DFT engineer is designed for test, and they're going to be figuring out how to test the product. We want to make reliable things for the marketplace, so we have to design how we're going to test that as we do. The DFT engineer is going to give me feedback as a designer on how to do that. And the component engineer is going to be looking at the components that are on the board. They're going to be looking at lower cost components. They're going to be looking at end-of-life components. They're going to be figuring out all the things that can go wrong with a component, and then sharing that information with the design team. And of course, company management is going to be making the decisions on the profitability of the product, whether it's the right product for the marketing, for the market, what features it needs, and then the end user, of course, is the one that matters the most because they're paying for it. And I'm going to use a lot of bicycling analogies. I like to ride my bike, and we have a two-seater bicycle here, and sometimes you're in the lead, and that's when you have your role, and other times you're on the back seat and somebody else is driving and you're just pedaling. So here's some different roles and what they do. So the project manager is going to be responsible for our schedule, the cost, and the scope. As a PCB designer, I'm looking at it, I'm going to be estimating how long I think it'll take to do something. I'm going to be doing the design layout, the placement, the routing, and then the documentation, which will actually let somebody build the circuit board. The electrical engineers can be designing the schematic, figuring out the logic, the component cost, the functionality, doing the initial debug. software to make sure that the board comes up. And then firmware engineers or software people that are going to be designing. So firmware is the software that goes onto the hardware to make it do what it's supposed to do. When you look at fancy GUIs, the interfaces and so forth, that's what they're designing. They might be designing test programs or making sure that this device is going to work through all the different areas that it is designed for. And then a signal integrity engineer, they're working on timing. I've already covered that. And the mechanical engineer, they're looking, they're designing enclosures. They're looking at selecting connectors, figuring out where those go, the assembly, the sequence of the assemblies, making sure that they can put it together, wiring between different parts of the units and so forth. Component engineer. So ROS compliance, that's the rules for what kind of toxins are limited in so there's rules for that. They're finding second sources, things like that. I already covered what test engineers do. And then supply chain. So supply chain, not really a technical position, but it's also really critical to make sure that all the parts come to be ready to build at the right time. And your supply chain is engineering that, making sure that all the suppliers are on board to ship parts at the right time. Because you might have, I just did a board that had 3,300 parts on it, and all those parts have to be shipped to our company at the right time and put together all at the right time. So supply chain makes sure that happens. They do audits on suppliers. They look at the risk in the supply chain, make sure that if that company has a fire, that you can still build your stuff because you have another plant or you have another source for that product. And they also look at ways to reduce costs. So outsource partner roles and responsibilities. So we don't work in a vacuum. We don't do it all by ourselves. And the best way to do something quick is to have somebody that's really good at something else, do that something else, and then you work in your energy advantage area. So this is a concept that is really powerful. To take what you're best at and work in that area, and then take and outsource the things you're not great at to somebody who's great at them. This one concept alone is so valuable too. So an auto routing specialist are going to figure out how to do the stack up in the auto routing and can help with that. PCB service bureau, if we get too busy at our company, we're going to outsource some stuff, and burst capacity is going to, that would be what we would do, is find somebody that does what we do and then, outsource it to them when we have those peak periods. A thermal engineer, they can do thermal analysis and run cooling solutions. An RF lab is going to measure the noise that the product makes so that it'll meet FCC rules and so forth, and not, be making noise where it shouldn't or accepting noise where we don't want it. Testing labs. Some laboratory equipment is extremely expensive. They might have millions and millions of dollars of equipment, electron microscopes and x-rays. If something goes wrong with a product, it really helps to have a good lab to figure out what happened. And these labs can help us with that kind of thing. An EMC consultant, they can help with compliance support or giving tips on how to improve the signal integrity of the design. Your prototype PCB fabrication facility is going to be where you get fast turn PCBs. Who does? Is there anybody that know what a PCB is? All right, good. That's pretty sure. So we have rigid and flash, and they give you quotes. So these are the people that do it fast, and then these are the people that do it for lower costs. So they save your money with your production fabrication. So they do panel drawings, design for fabrication, the stack ups and things like that. They can help us with that ahead of time. And then prototype PCB assembly, they're going to help build this. So you have a bare board, and then you have a stuffed board where it's got all the parts on it. And the assembly house is going to do that, and they can help with part buys and things like that. And then you have, they can take their software that helps with the design. They can say, well, we're going to have problems with this or that, and they give us feedback on that. And then they also do PCB inspection when they get the boards in, and then they do conformal coding and module assembly so that we take the part back and we can stick it in our car or wherever it has to go. And compliance engineers help us meet regulations that are out there. Kind of speed it up a bit. All right, so design team interactions. So as a PCB designer, I'm working with all these different people. So manager says, I need this project. Project manager says, I need to talk to my electrical engineer. What's it going to take to get these done? He's working with all these people, and then the PCB designer is working real close with the EE, and then the ME, and then the SI engineer, and then once all that work is designed, then working very closely with fab and assembly to get the board built. All right, so talking about teams, so creating a successful team is kind of like shifting the right gear on a bicycle. There's 4 stages. The first is the forming stage, and this is where you're unsure if you're in the right place. You just got your bike out of the car, and you're starting, and you hear a big gnashing sound as the gears go into place. That's the forming stage. And then the storming stage is when you're all yelling at each other, and you don't like the way somebody else is doing something. And there's friction, there's tension, there's errors, and omissions. Just kind of getting things in the right place, but they're not there yet. And then the norming is you're working, there's corrections, there's feedback, but where we all want to be is on a performing team. That's the highest stage of a team, and that's where everybody's pulling together. There's high trust, it's highly efficient, it's full speed, and championships are won by these kind of teams. So when we think of San Francisco Giants, they're an extremely efficient team working together. They turn the double play all the time when it's supposed to be turned, right? That's what we're looking for on our team, is to get to that point where you have full trust in the person next to you to be in the right spot, and you can toss the ball without even looking because you know they'll be there. For instance, okay. So success is the accomplishment of one's goals, and what's that take? Well, in order to be a success, we need to measure different things, and some of the things we measure in a printed circuit board project is it functional, is it durable, is it effective, is it affordable, is it profitable, can we repair it, is it safe? Is it compliant? Is it, can we sell it in all the other different areas? There's different kinds of compliance. Is it first to market? Huge advantage if you're the first one to the market. Is it easy to assemble? Can we make this thing? Is it in the right form? Does it have the right fit? Is it buildable? So those are all different measurements of success that we're looking for. And our successful designs are going to be in 3 different buckets. In our first bucket, design failures. That's the crappy stuff that doesn't work. And this is wasting talent. It's bad for people's careers. It decays trust. This is not where we want to be. That's the lump of coal down here. Most designs are in this marginal area. They're mixed results. They're not great. They're not bad. They work, but they don't work fantastic. And then successful designs is really where that's the pot of gold, because we're meeting the intended purpose, and it's working properly, and we have assignable clarion roles. It's exciting to work on these kinds, and you're aligned with the mission. If you're working on successful designs, it's usually going to be meeting all of those criteria, and it's going to be a lot of fun to work on something like that. So how do we get a design done? Well, the first step is to map the area. What is it we're going to be doing? So we take a look at all the different things that have to be done, and we catalog that in a plan. And we take, so there's a part definition phase, part selection. I'm going to kind of skip through this and let you just read it. Any questions on this? I'm going to move on. We can come to this later. I need to accelerate on some slides. This is the one I do. So basically, we get the area, write our plan, and then we write down the steps it takes to get all that stuff done. So how fast do you want to go? When we have a design team, there's 2 aspects to that. There's the production aspect, and then there's the production capacity aspect. So before he passed away, Stephen Covey wrote a book called The 7 Habits of Highly Successful People. And this is the principle he laid out, and it makes a lot of sense. So this is the design cycle, and you got the working part of it, and then you got the direction part of it. So we can improve our process, how we work together. We can improve so we work on all these different, these are your deliverables. We have the staff that helps us with that. Your productivity involves getting more done faster, better, and easier. And our goal is to always improve our process. Sometimes we're so busy working, we don't have time to work on the process. And there's engineers that just work on process. There's engineers that just work on work. And sometimes they meet. And so to build the capacity, that's like the framework. How do we make better plans and procedures and stuff? Structures for that. We can build templates, we can put libraries together and get our tools, better tools and training and design standards, industry standards. So you're going to join the industry. If you join right now, you'd probably be a little bit too green. It wouldn't be very efficient. But in a few years when you graduate, you'll have all the tools, and you'll be able to rock and roll on this and really go fast. You'll understand, both of these columns will be able to be effective. So when we want to improve a process, we look at what our what is state, where you are, and we look at our to be state, where you want to be, and then we want to design a plan to get there. All right, it's one of my favorite slides. Okay, so how do we accelerate our schedule on a project? We improve the process skills, and we can use templates. I already talked about this. Take out as much lag as possible, so keep people busy on stuff that is going to move the project forward. Eliminate meetings and disruptions as much as possible. Tag team the design, so you can work on it 24 hours a day if you tag team it. Maybe one person works at night, the other works during the day, or you share it with somebody in different geo. You divide and conquer the work, and you set up design reviews, make sure you're still on the right track, make sure that you're clarifying the instruction. And then I put it down at the bottom, you can also work longer hours, but that tends to be a short-term solution, not a long-term method. There are companies that think that's a great thing to do, but you will get burned out if you don't plan your work and then work your plan. Lead times, I'm going to kind of skip this. It's important to estimate lead times if you want to accelerate the schedule. You have to know how long stuff's going to take, and then there's a lot of different aspects to speeding that up. I'm going to skip that for this group. And then this is part of the philosophy of designing it. So we want to turn our problems into opportunities. If you see a problem, it's actually an opportunity. So if I have a design process and I'm missing data, well, I can put a checklist together for that. Or if I have incorrect data, I can do a design review. Or if there's obsolete data, I can put a confirmation process. So there's some data issues or people issues. If somebody's not being professional, we counteract that with a high professionalism. Or if somebody has ulterior motives and they want to sink your project, you want to address the underlying concerns and find out why. Or if you're not getting buy-in on a project, present the value case. Make sure that they understand why it's important that you do and a good job on it. Or if there's lack of support, be the person that's supporting it. Or if there's distractions, exercise discipline. So you have homework, problems. Well, how you turn into opportunities. Look at what, if you're in an environment that's hard to study in, go acquire a room, right? I mean, you control that. So that'd be like an example that you would use this philosophy on. All right, so collaborative tools. You're the generation of communication, I think. And there's, email is getting kind of dead because it's so busy. But, be real concise. I have thousands and thousands of unread emails because I didn't like the title, so it just sits in my inbox. But keep one topic per thread. If you have a big project, a wiki page is pretty handy for keeping track of that, or WebEx, or some different tools like that. File sharing tools, Dropbox, cloud-based storage, that kind of thing. PLM is program lifecycle management. They figure out that the right data is in the right place for the right people. That's what those professionals would do. Messenger meetings, okay. Common meeting type. So a project definition meeting where we figure out what we're going to build, schematic architecture, review, PCB design kickoff meeting, scheduling, PCB placement. So after I get done with the placement, I say, hey, this is where I want to put all the parts. Is that good? If it's not good, then I'm going to have to move them before I tack them all in. I finish the routing, we have a final review, and then a post-mortem is where we figure out what went well, what didn't go well. And I like to say that the value of a meeting is usually inversely proportional to the number of attendants. All right, so special case meetings. I think we're doing good on time. So special case meetings would be like schedule, like if you want to recommit, or when we're looking at the schedule, we can do three things. We can recommit, or we can renegotiate, or we can just unmake the schedule, and we're not going to do it. There's different problem-solving techniques that are employed in the industry. And solving problems is what we do. Root cause analysis is going to look at what's the root reason why this was a problem. What can we do to fix it? And you dig down into that 5 whys. You keep asking why, and why did that happen? Why did that happen? Why did that happen? Why did that happen? And you keep going. It usually takes about 5 questions of why before you get to the real reason of why something happened. TRIZ is originally a Russian methodology for looking at the problems from a physics standpoint and then examining if we applied a physical principle from another area of physics to this problem, how would it change the problem? And there's a whole study on that too. It's another problem-solving method that's really quite interesting. And then corrective action reports. Might be a meeting where we want to, this isn't working, what are the corrective actions we can take to make it work? And then FMEA is a failure modes effect analysis meeting. And we take a RPN, which is the risk, the probability, and we assign a number to it. And then the severity, and we put this all in a spreadsheet and we say, this could go wrong, it could be that bad, and there's no way we can detect it, or it's easy to detect. And we assign a risk to it, and then we can assign a cost to that and say, well, we want to fix these problems first because they're the worst, and the worst things can happen. And that's one of the tools we use in industry to figure out what we're going to do with regards to process improvement and making things more reliable. Changing scope, so this would be like if we want to add a new feature to a product, is this a change in scope meeting? So an ECO will happen, and that happens quite frequently because engineers seldom make up their mind until it's too late. And then continuous improvement, and then a SWOT meeting would be strengths, weaknesses, opportunities, and threats. So every organization has these 4 items. In a SWOT meeting, you just kind of all step back, you go into a room like this, and you hash out what are the things that are going right with our business, what can we change, what are the things that we're weak on, what are the opportunities if we do this, and then what are the threats to our business. So those are all things that are figured out in SWOT meeting. Some organizations will do those every 3 months, every 6 months, every year. It kind of depends on what it is you're doing. Design constraints, I'm going to skip this. This is really technical stuff about how to speed up designs and constraints. That's pretty specific to what I do. And then design constraints definitions. This is interesting to cover for STEM students because a stack up is the different layers that are in a multi-layer printed circuit board. And we can change the materials, the glass that's in it, the resin content. That changes how fast electrons will move through it. We call that decay. It's the stiffity resistance. We sometimes call that E sub R. That's the thickness of the board, how we meet target impedances. It's important not to mismatch things like that. It's kind of getting a little bit technical, but if you're sending a signal along and all of a sudden it encounters a big bump, it's going to jump, and that's kind of where our signal goes. Boom, boom, and we might have a level here, and if it goes above that level, it's no good. And now you're not doing what you wanted to do with your circuit board. So these are all signal integrity issues, and these are the different things that we can do to address them. Power, do we get the voltage and the current, at the right time, and at the right, do we have enough, can we carry enough energy with what we're building? With our cars, it has the motors, there's a lot of amperage and a lot of current going through that big battery to power those wheels, and if you make a mistake on this, stuff would melt, so you have to figure that out. And then, the timing, when do we turn that motor on, when do we turn it off, things like that. These are the functions of these critical nets, and then heat. Things get warm when they're working hard, and how do we get that heat out of it, what do we do, and so these are different design constraints that we would be putting on our designs. And then using consultants, so I talked to Bill about how it's efficient to do that. Generally, hire them before you need them, so you get used to working with them, let them know when you're going to need them, establish a communication matrix, so who's going to talk to when, who for what, and then an escalation path and backup people if you're, and then training on the details of working with you. So I work with an outsourced vendor. I have to teach them how I want my stuff to be done. And then I want to confirm that the work's going to be done by the people that I have assigned it to. Make sure I get the right things. And then share the details of what you expect. And you can never be too precise about that. If you're giving instructions, give really clear instructions. And then remember that what's routine for you, it might be new to them. So you have to explain it. And then use outsourced partners to get more stuff done faster. Design for manufacturing. So if you find your problems earlier, it costs a lot less to fix than if it goes in later. And if stuff's out in the field, it's even more than that. And then scheduling tools and methods. So who knows what a Gantt chart is? What's a Gantt chart?
I haven't used one in years, but it's a chart that's basically what I'm using to.
Yeah, it helps schedule, right. So it's a chart. It looks kind of like an Excel spreadsheet, but you put tasks in, and then there's how long is the duration, and then it lines everything up. When this is done, then this is done, and it sends. You can set up the schedule based on, I think this is going to take long, and there's contingencies, that are put in place and milestones, and then you set up your leads and your lags. And my advice working with those is to keep the task anywhere from a half hour to 4 hours to complete, so that every day something gets done or should be done. If it's not, then you really want to look at that. And then You can also use this spreadsheet. Not small projects, I think, pen and paper to-do list works just fine. So those are some different tools. And then design reuse. This is where you get efficient, is to take something you already did and reuse it. Repurposing is a good thing in industry and business. It's a bad thing on your term paper. So key success principles. So after this, we're pretty much done, and I'll take questions in a little bit. So take complete and total responsibility for your results. That's probably number one importance, is to just be responsible and build trust with people by doing what you say you're going to do when you say you're going to do it. Work at a consistently high level. So you control how hard you work and what you do. And we're not going to be at a 10 every day, but we should try and get ourselves above a 7 every day, or higher, and then just be at a high level consistently, and then you get the leverage of momentum working for you, and really helps. Never be afraid to ask a question. This is huge, folks. I mean, don't be afraid to ask a question, because that's the only way you find stuff out, is to ask about what you don't know. And then I like to have a servant's heart. I always desire to do the most I can for others and fulfill their needs. Trust fully, but offer feedback as needed. Don't assume someone else checked it. Build momentum from one success to another. Treat people right, they never forget it. Version 1 is better than version none, so don't be afraid to just do it and get it out there. And then, sloppy success is better than a perfect failure. And then seek out ways to combine advantages. So if you put multiple technologies together, that's going to be a combined advantage. And find out ways that you can put more than, 1 plus 1 with synergy can be 3. And that kind of a concept is that combined advantage concept. And then, for the discipline, just practice delayed gratification, if you want to have a great life. If you're living just for today, yeah, that might taste good. If I eat donuts and ice cream every day, it might taste good that first day, but I'm pretty soon not going to like the results after a few. If I do that for a year, I'm not going to look the same. Training for excellence. Getting to the next level is a process. More repetitions is going to make you better. If you have a problem in school and that math problem is hard and you're not good at it, do it more. Do it a lot more. Really, really understand it, so that if somebody slaps you with that problem, it's yours. Ask more questions about the work. Attend seminars. So there's a lot of talks like this one where you go and you learn something. Be there. I commend all of you for being here. And then read publications, books, magazines, websites, and then you really want to be good at something. Teach others the skills and concepts, because once it's taught, it's twice learned. And then be of service and understand the service of others. I find that to be tremendously beneficial. Okay, and that's my talk. I hope you enjoyed it. And I'm going so we have a question over here. What's your name?
My name is Kirk. My question is, why is Toyota pushing hydrogen technology and skeptical of batteries being able to be the future model for cars?
I'm not going to say something negative about another company. Other people have already done that. If you research the answer, to me, hydrogen fuel cells is not the answer. There's very limited places to get hydrogen today. Hydrogen, by its very nature, leaks out of things. It's the smallest atomic particle, and it tends to go through other particles. So it's hard to box hydrogen up and keep it there. It's not terribly efficient. It's a great power source. It also is extremely explosive. So there are some inherent dangers with that. It needs oxygen and a spark. Hindenburg, for instance. Toyota has invested a lot of money over a lot of years in that. We'll see where it goes. Yeah, next question over here. Yes.
What do you find that's so compelling about Tesla compared to the conventional automobile? What's the biggest difference that you noticed?
So it's all electric. It's a ground-up design. So nobody else has really done that in a long, long time. Electric vehicles have been around for 100 years or more, but nobody's done a high technology, best class design like we have until we did it. And then, and it spurred other manufacturers on to do that. Our goal at Tesla is to move the world towards sustainable transportation. So it's really fun to work on projects like that. Over here, yeah.
What's the difference between working for online and working for your own business? Which one is the more?
Oh, I'm a much harder boss
Sorry.
for myself. But I think how hard you work is going to be dependent on your personal values and how much you desire to serve others. So for me personally, when I had my own business, I was typically working 100 hours a week. I typically don't work that many hours now. I have 4 children and a wife, and while I enjoy financial stability and so forth, I typically won't work that many hours. Sometimes I will, if I'm trying to close out a project or something. But for me, the best thing of working at Tesla is the team that I work with is really top notch. I work with a lot of subject matter experts that are the best in their field, and to be in an environment like that is fun because I can trust the people I'm working with to do the best that they can do, and they trust me to do that too, and I never want to not honor that trust that's in me. So people don't ask me to work super hard, but I enjoy doing it because I know what we're going to get out of it at the end of the day. Yeah. Yes.
A lot of people interested in STEM careers tend to kind of stick in, quote unquote, stay in their lane and only think about sciences, but a lot of people also are concerned about the ethics of the company they want to go work for, all that kind of stuff. So my question for you is, with all the stuff that's come out in the last few years about high tech moving onto the peninsula, bringing jobs but also increasing income inequality, can you give some comments or thoughts on finding a company that actually reaches out to women and minorities to get jobs, that works with students, and that when you outsource to people, you're hiring the right people. When you're going through your supply chain, you're hiring people who make a living wage. Can you comment on that and the importance of finding a company that does that?
So everybody in this room is interested in about the job that they're going to get. First off, they want a great job. You control how good that job is going to be by the value that you bring to the table. At the end of the day, it's not about equality or anything. It's about the skills that you possess and how well you work with other people and how well you can communicate that and what you can do. I don't even have a degree in engineering, but I understand every principle involved. I understand the science, the technology, the engineering, the math. Whatever it is needed, I've gone and studied it and made that a core competency. And you owe it to yourself to do the best you can in every situation to get as much knowledge as you can out of what you're doing, and then apply yourself as fully as possible so that you can bring more value the next time you have a job. So everybody's going to stair-step up from where they're at, right? We're all at a different level. We're all trying to add value to whatever company we go to, whether it's a startup or a company that's been here for 100 years. And the companies, Tesla's a merit-based hiring company. So I work with all different nationalities, people of all different, everything. But they were hired because of the merit of them being able to do a good job. I don't want to work next to somebody that's not as good as the best person that could have been hired based on some other factor. Me personally, I think it's important to build your skills up. Now, if somebody steps in the way and cheats you out of getting a better education, that's not right, right? That more to me is really bad. But we all have to take responsibility to do the best we can, with what we have. Did I answer your question?
Kind of. I'll take it.
Okay. Yes. Go ahead.
Two-part question. What are you doing to advance battery technology within the use of your product, and what is your favorite car?
My favorite car? It's Tesla Model S. I've got all kinds of parts in it. It's fast as could be, and it's a thrill to drive into. It's to me when I was working on it. The first part is I'm working as hard as I can to do the best I can on. I worked on a lot of parts for the car, and I'm doing the best I can. But when it all comes together, you don't know how well everybody else did And what I found is that everybody else did a really great job too. You know, so for me, that was super thrilling to see the car, you know, come together the way it did. We just launched a new car, you know, last night, our Model X, which, again, amazing vehicle, groundbreaking in a lot of different ways, and it's fun to be a part of something like that. That's one part of your question. Now, the other part, what was the other part of your?
Advancing battery technology.
Oh, so advancing battery technology. I'm not really about to talk about specifics in that area. We're building a really big factory in, out in Sparks, Nevada, called the Gigafactory. We're going to be making a lot of batteries. Next question. Over here.
I'm just wondering, as part of the design process, how do you deal with scope creep when you have such an important job?
Without like screaming and yelling?
Ideally.
So scope creep is when you have a project and you start it and you have maybe 10 requirements. And then maybe it's a 6-month long project and every month they add another requirement. Now you have like 16 requirements, and then the 6 new requirements make you throw out 5 of your old requirements, and you have to change it all. So, scope creep, the best thing to do is reassess your schedule at that point. So that was one of the special meetings I talked about, is to have a schedule meeting. You say, well, if we add this, this is the impact. You're not going to be able to finish on time. You will miss this opportunity if you add this feature, right? So that happens all the time, right? I mean, you want to make things as best as they could be, and you go down one path and you realize, I need to change my tactic, this didn't work, and you go and you circle back and do it a different way. It's kind of what makes engineering fun, but it's also what makes it really, really hard work. So, I have the utmost admiration for people in my profession. But any other questions over here? Yes?
Thank you very much for speaking. Tesla is working at the cutting edge of technology, and going into engineering, I'm really excited to work on technologies that are developing. What kind of expectations do you have when you are when you first started working on the Model X, and as far as like a time frame, setting time-bound expectations?
So with regards to time-bound expectations, we can control what we do, and we can't control everything that other people do. So I go into it, I put my head down, I do the best I can every day, and I take what comes. And other people will be upset with that or be happy with it based on their expectations. I can control what I tell them about it. I cannot control what they think about it. So setting expectations is really critical to having harmony with your team. And you're going to be better at estimating things the longer the more experience you get at estimating. I kind of went through that estimation page pretty quick, but that's a really key aspect of planning a project, is to be able to estimate how long it's going to take so that you don't disappoint people. And then other people are putting a lot of money into the product being ready at a certain time. So if I say I'm going to be ready in a month, and they buy all the parts and they sit there for 2 months, I've wasted that resource of 2 months of manpower and energy. If they hold the factory open for my build and my design's not ready, I just wasted an enormous amount of money. We do that all the time in industry. We mess up the details of what we're trying to do. So engineering, as an engineer, you're ethically bound to do the best you can in the time that you're given so that you don't mess other people's schedules up, right? And you keep your company profitable. It's a huge, huge deal to hit deadlines when you say you're going to hit them, right? The marketplace is looking to see if you can be trusted. Everybody wants the product to be good, but they don't want it to take forever either. So yeah, it's something. There's a balance in that, and as most things, and so you're always balancing out, being able to do that the right way. Yes.
All right, so it is just about 6. I think Carl's going to stay around and answer some questions. I know some of you had some more questions one-on-one. A couple last-minute announcements. There is, starting at 6, a DACA workshop up in the library. And there's also a Kenyatta women's volleyball game, also starting at 6 in the gym. And if I could ask you guys, to clean up all of your stuff when you go away. And let's give Carl a quick hand.